Hi ladies and gentlemen, this is Mr. Green again. This is another in my series on Algebra 2. Where are we at? Well, right at the moment you should be through with Unit 5. We should be moving on to Unit 6 at this point. I want to keep reminding you, you can make corrections in my course. It's not in the course, it's not in the syllabus, but if you have a test that you didn't do well on or a quiz you didn't do very well on, you can retype those in a Word document. Show me how the problem should be worked rather than just giving me the answers. Show me how they should be worked. Send it to me as a document in Kmail. Tell me that you're in Algebra 2 so that I know that, and I will give you credit for it, okay? But you do need to send it to me before I can do that. Okay, moving forward. We're in Unit 6. And in Unit 6, we're going to take up the concept of operations with rational expressions. Well, this is Part 1. Part 1 deals with these type of operations that are adding and subtracting. And I know you guys have dealt with fractions in the past, so when we add fractions, we've always had to find a common denominator if they didn't have one. If they don't have a common denominator, you have to find that common denominator. We're going to do the same thing with polynomials. You can see up here, we've got x squared plus 3x, and we've got 4x as the denominator in both situations. That's a common denominator. You can use that, and you get x plus 3x. That factors to x and x plus 3. Oh, look, x is in denominator and numerator. They cancel out, giving you x plus 3 divided by 4. You can do that sort of things if they have common denominators. It's when they don't have common denominators that you will start having some issues, okay? So we'll look at some of that as we go along. Let's look at the first one here. What are we talking about? We've got x minus 3 and we've got x minus 3. Those are my two denominators, x minus 3 and x minus 3, okay? So since those are common to each other, they're the same thing, all we've got to do is the operation. And the operation in this situation is an add operation. So I'm going to take x squared plus x squared. Well, that's 2x squared. I can do that. 2x plus minus 3x. That's minus x. I got that. And then negative 15. Negative 15. And that's all divided by x minus 3. Are we done? No. Unfortunately, when you added fractions, you always had to check to see if you needed to reduce the fraction. That's what we've got to do here. I'm going to multiply the negative 15 times 2, giving me a negative 30 that I'm multiplying to. Well, they've got to add to negative 1. Well, what two numbers, when multiplied, give me negative 30? Well, and add to negative 1? Let's see here. I don't think I know. Oh, wait a second. 6 times 5, and negative 6 times negative 5 gives me a negative 1 when added together. That would be what I would be looking for as a possible factors. Let me show you what I do here. I use what I call the mama rule. I just did mama, and what I'm going to do down here is I'm going to use those factors, negative 6 and 5, and I'm going to put negative 6x plus 5x minus 15. Where did I get the negative 6 and the 5? Negative 6 and 5. Okay, where'd the x squared come from? Well, the 2x squared was in the original equation, the 15 was in the original equation. I am then going to group the first two numbers together and group the last two numbers together. Why do I do that? Well, because then I can see in these first two numbers I've got an x and a 2. I'm going to pull out the 2x out of here, and that's going to leave me with an x minus 3. And in the second set of numbers, I can see a 5 in both of them, and when I pull that out, I get an x minus 3. Oh, look, they have a common factor. Well, that's nice. X minus 3 is one of my factors. And then I've also got, what's left? Well, I've got a 2x plus 5. I have my factors. So going back to over here where the equation was, I've got x minus 3 times 2x minus 5 divided by x minus 3. Well, guess what? The x minus 3 will cancel out in this situation, and my answer will be 2x minus 5. That will be the answer to this problem. This is no different than having 8 divided by 2 as the result of an operation, and you're going, oh, I can factor that out, and it becomes a 4 as my final answer. This is the same process. Okay? I just factored the original numerator up here into its factors, and once I got its factors, I then found the answer by a little bit of division. Okay? Let's look at a couple more, see what we can come up with. Oh, look at this. We don't have common denominators anymore. I've got an x plus 1, and I got that over here, but I don't have the x minus 3 over here. This is no different than saying, well, if you've got 3/7 minus 2/9. Well, you've got to find a common denominator between the two of them. The trick I like to use is, since they're already factored in this situation, is I'm going to multiply this by x minus 3 over x minus 3. What did I do? I just multiplied by 1, because those two cancel out to 1. But I can use the distributive property on the top over here. And then I do have a common denominator, and it becomes 7x plus 3 minus 5x minus 5 times minus 3 plus 15 divided by x plus 1 and x minus 3. Okay? Combining my like terms, 7x minus 5x is 2x. 3 plus 15 is 18. Oh, wait a second. I can factor 2 out of that at least, right? So I'm just going to mark that out right away and say 2 times x plus 9. Okay? Divided by x plus 1 and x minus 3. Now that I've got it like this, I don't have anything that I can divide out. This would be my final answer. Everyone with me on this? Good. I'm glad to see that you're doing this fine. Okay? Now, would I do anything different than this? I would not expand this out any other way. I'd leave it like this. Okay? Because if there is a common denominator, I'd cancel them out. I'm sorry, if there was a common factor in numerator and denominator, I'd cancel them out, and then it would be reduced. Okay. Oh, man, this one looks like a toughie to do. Let's see if we can slug our way through this one without any difficulty. So I've got 8, and then I'm going to factor the denominator down there, and I'm going to pull out an a squared, and that's going to give me, matter of fact, I'm going to pull out a 5a squared. That's going to give me an a plus 5. Okay? And I'm going to hit a subtraction, and I've got an a plus 2 on top. And then over here I've got an, oh man, that's got an a all throughout, so I'm going to take an a out of it. And that's going to give me an a squared plus 10a plus 25. Oh, you know what? I recognize that one. It's going to be a times a plus 5, a plus 5. Okay? Well, that's nice. I can see that some things are common between the two denominators, but if I want to write my least common denominator, I got to find all of the things that are common and write it down. So I'm going to say I need to have a 5 common to both of them. That means I'm going to be multiplying this one by 5. Right? And I need to have an a squared common to both of them. That means I need to multiply this one times a squared. And then I need to have an a plus 5 common to both of them. Well, they both have that. But I need 2 of them. This one needs an a plus 5. So I'm going to be multiplying this one times a plus 5. A plus 5. And over here I'm multiplying times 5a squared. Okay? So I didn't change the value any because all I did over here was multiply by 1. Right? And all I did over here was multiply by 1. Oops, not the 25. Excuse me. went off the side of my thing. There's my a squared. 5a squared. See, that's 1. So I didn't change the value any. I just, I'm just adding, getting a common denominator there. So 8 times a plus 5 gives me 8a plus 40. Okay, and I'm going to be subtracting, and I'm going to take the 5a squared times a, and that's going to give me a, you know what? It wasn't a squared, it was just a. I knew there was something wrong with that, because I've got an a down here, don't I? Yeah. Okay, so I'm multiplying 5a times a. That's going to give me a 5a squared. And then I'm also going to have a minus 10a. Okay, well, let's put this in a form that we can actually factor it, because I think there might be some factors in there. I've got a minus 5a squared minus 2a plus 40. Wow. That's going to be kind of hard to factor, because I'm going to multiply the minus 5 times the 40 and get a negative 200. And that's got to add to a negative 2. Remember, that's multiply and add. Well, multiplying to negative 200 and adding to 2. That means they've got to be pretty close numbers. Let's see here. 4 times 5 is 20. 40 times 5, well, that's not quite going to give me what I want. Let's see here. If I take that to be, well, 5 and 5, it's 7. Oh, what's here? 5, 10. 10 times 20. 10 times 20 would be 200. Not quite what I'm wanting, because that doesn't add quite right. Let's see here. What else could I use? I'm going through factors in my brain. You can see, you hear me doing it. That's what you've got to do. You've got to look for what the factors might be, right? Well, let's see here. I got 10 and 20. Those aren't going to work. So let's see here. If I took, do I really have that multiplied out right? Because that's not what I had written down on my sheet of paper. Okay, let's see here. Let's see here. 5a squared minus 2a, and then a positive 40. Yeah, that's what I've got. Let's see here. Make certain I multiply that right. Let's see here. That's 5a squared. That's that. Okay, that's 8. That's 40. Yep, that's correct. Okay, so let's see here. Factors of 20, of 200. 2 and 100, 4 and 50, 8 and 25. Okay, still getting there. Okay, 5 and 20 and 10. That's not quite it either, is it? Wow, computer started doing something funny there. Let's see here. Take 2 out of that one. Still going to give me 20 and 10. Is there anything else I can get to? I don't think there is. Pause for a second here while I do some factoring in my head. Okay, unpause. Now, what I'm getting here is negative 202, and I can't find any factors that give me negative 200, like 20 and 10. Okay, if it was negative 20 and 10, that would add to a negative 10. And if it was a negative 10 and 20, that would add to a positive 10. So none of these are adding up to negative 2. And that's a little disconcerting to me, because I have a factor written down on my piece of paper over here. But what it means is I'm not finding a factor that I think will work with this. Okay? And so what I'm thinking is that this is the lowest common denominator. Well, I'm going to factor a -1 out of it just because I hate starting things with a negative. So that'd be negative times 5a squared plus 2a minus 40 divided by 5a squared a plus 5 squared. Okay? And that would be my answer when I subtracted those two things. Yeah, it's ugly, but that's the way subtractions go sometimes. Okay? It just shows, even if you think it's an ugly answer, keep working at it. You might be able to prove that it's easier. Okay? So let's look at these two real quickly because there's a couple of interesting little tricks that you can play here. You notice how I've got 3t plus 1 in both of these two? Well, all I've got to do is subtract the numerators then. And what I would get would be 5t squared minus 5 minus 3t minus 2 divided by 3t plus 1. Well, when I write this all down in combining the like terms there, I get 5t squared minus 3t minus 8. And I'm thinking that 3t minus 1 is not a factor of that. Right? Because I do not see anything multiplying to give me 5t squared that starts with a 3t. So I'm thinking that this is going to be my lowest factor here, 3t plus 1. And I would say that is my answer. Okay? Looking over here, I see an x minus 1, x minus 1. I'm missing this 2x plus 3, so I'm going to multiply this side by 2x plus 3 divided by 2x plus 3. And I'm just going to leave my denominator in that form, okay? X minus 1, 2x plus 3. I'm not going to change it any at all. I'm going to go ahead and use the distributive property and get 10x minus plus 15 minus 2x. And that's going to be 8x plus 15 divided by x minus 1 and 2x plus 3. I don't see any common factors between 8 and 15. That'd be my answer. Okay? Two more and we'll be done. Okay, I've got a 5x minus 4 on this side and an x plus 2 over here. The interesting, easy way to find the common denominator in this situation is going to be 5x minus 4 times x plus 2. That's the easy way to get the common denominator. Just multiply the denominators together. Well, that means I've got 4x times x plus 2. And I've got, subtracting from that, 3x times 5x minus 4. Lousy parenthesis. Okay? Well, if I multiply 4x times x, I get 4x squared. If I multiply 4x times 2, I get 8x plus 8x. And I'm subtracting, well, 3x times 5x is 15x. And 3x times minus 4 would give me a 12x. Minus 12x. Parenthesis. My x kind of goes off there. 15x squared. Okay? But this is being subtracted, so there's a negative sign that's going to get distributed through all of those. Okay? So I've got 4x squared minus 15x squared plus 8x plus 12x divided by 5x minus 4 and x plus 2. Well, this becomes negative 13, nope, negative 11 x squared plus 20x. Okay, well, I could factor an x out of that, and it's not going to help me a whole lot. Okay, over 5x minus 4, because it's not going to give me 5x minus 4, and it's not going to give me x plus 2. So, final answer, to do. But this trick was to find the common denominator here. Over here on this one, golly, I wish there was an easy way of doing it. First thing you got to do is factor the denominator. Okay? So we're going to have a 2z over here and a z here. We're going to have things that multiply to give me 5, but add to give me this negative 5, and then but add to give me that 9. Well, I got that 2 involved in there. That's going to make it a little bit more difficult. Okay? Well, I think the multiples of 5 are 1 and 5, right? So if I multiply 1 times 2 and 5 times 1, I get 5 and 2. That's going to give me 3. That's not going to be enough. Let's see here. I need something that's going to give me 9. Let's see here. 10 and 9. That'd be 10 and 1, right? So if I put a 1 here and a 10 here, 10 times 2 is 20. That didn't work out right. Try that again. Okay? Let's see here. They got to multiply to give me a negative 10. And they got to add to give me a 9. Okay? So if they're multiplying to give me a negative 10, that's going to be a negative 10 and a 1. So my factors are going to look like this. 2z squared minus 10z plus z minus 5. Okay? So factoring out a 2z out of this one, I get a z minus 5. And factoring a nothing out of this one plus 1, I get a z minus 5. And so my factors are 2z plus 1 and z minus 5. And over here on this one, I factor out a z squared, and I get a, my factor out a 6z squared, I get a 2z minus 1. Well, that's nice. They both have a 2z. 6z out of this one gives me a 2z. 6z of that is a minus 1. Oops, should this be a minus 1 here? Let's see here. That gives me a negative 10. Yes. I'm sorry. 2z minus 1. So my common denominator in this situation is 2z minus 1, z plus 5, and then a 6z squared. Well, that means I needed to multiply this times 6z squared, and I need to multiply this times z plus 5 to get my numerator. So that's going to give me a okay, 6z cubed minus 2z squared minus z times 6z is a 12z squared, and minus 5 times 6 is a minus 30z. Well, there's a common denominator in that top of a z. I'll factor that out. I'm going to combine my like terms, and I'm going to have z times 6z squared minus 14z minus 30 divided by 6z squared 2z minus 1 and z plus 5. Well, one of these z's is going to cancel out with that one. So those are going to cancel out and be gone. Okay? I can see at least a 2 in each of these. So that would be a 3, that would be a 7, and that would be a 15. And that'll make that a 3 down here on the bottom. Okay? So just going to another page here. Hang on a second. Insert another page in here so that I can do this. Okay. My factors on top are 3z squared, z squared, 7 minus 7z minus 7z, and a minus 15 divided by, let's see here, I've got a 3 is 2z minus 1. I've got a 3, a 2z minus 1, and a z plus 5, I believe was the other one. Yes, it was. Okay, so those are my factors. Well, I can't see anything that's going to have a 2 in it because I've got a leading coefficient here of 3, right? So I'm thinking that this one might have a factor of z plus 5 in it. I'm taking the context clue right here. Okay? If I were to get that, I would have a 3z over on this other side, and that's going to give me 15z. That means this one has to add 8. So minus 8. Yeah. No. 5 to, that's way too big. That's got to be a 3 to get to 15, right? And 3 times z and 5, 15 minus 3 is not 7. So guess what? That's not a good factor. Neither is that one. That means that these are not going to be factorable by that. So that would be my ultimate final answer. Okay? Yeah, these look ugly. Okay? Subtraction usually is. And I want to remind you, when you're having trouble with this, bring it to Toga. Bring it to Toga every day of the week next week if you need to, and we'll talk about it. Make certain we understand how to do the subtraction. Remember, subtracting fractions wasn't easy when you were doing it in elementary school. Now that you're doing it with polynomials, it's not going to be any easier. Okay? We will get to some easier stuff in this unit. This is the hardest part of it. Okay? Once you get the hang of it, it really is not that bad. It just is very, very tedious to get through. Don't forget, give me that course that you're in Algebra 2 every time. It really does help me. Okay? And I'll talk to you next time.